Hello, welcome to another episode on Taxonomy Online Mathematics. We are still taking questions on integration under the area under a curve, but this one area between two curves. We did the first two episodes on that. We want to take another question and see how best we can provide answer to this based on the principles we learned in the first episode. You can check it out. It's on my playlist. So find the area enclosed by the curve y equals to x squared and y squared equals to what? 8x. You know the steps we've learned is that we first have to find the x coordinate, which is the intersection of the two curves. So we are going to have first one, you know, y is equals to x squared. Here is y squared. So for us to have the same y, either we square this to make it y squared, or we find the root of this, and we know this is not a perfect square. So the best way is to square this y so that both could be y squared. Simply mean that if I square y, it will be equal to this. And if I square this y, it will be equal to what? X exponent what? 4. What I mean is that this is going to be y squared. Then this is going to be x squared squared. I am squaring both sides. So if you square y, you have y squared. This will become what? X to the power 4. So y equals to 8x, y squared equal 8x, y squared equals what? X exponent 4. So we can eliminate the y squared and operate this. So this is going to be bringing this closer to this, will mean that I have x exponent 4 minus 8x equals what? 0. So we are looking for the values of x. So what do? We can factorize x out. So if x is out, dividing this give you x exponent 3, then minus 8. All this must equal 0. So since these two brackets are multiplied, the first number will either be equal to 0 or the second number. So here your x will be 0 or x exponent 3 minus 8 equals what? 0. We know that this can transpose to become a positive. So we're having x exponent 3 equals what? 8. Then if I take a cube root of both sides, your x is going to be the cube root of 8, and that will be what? 2. So simply put, the values of x is going to be 0 and what? 2. Meaning we can have the limit of integration between the interval 0 is less or equals to x, less or equals to what? 2. So this is the interval through which we are going to have our definite integral. So now we need to also sketch the curve or sketch our graph to see which regions we are going to have. The region is always between 0 and 2, but which regions in the graph are we finding its area? So if I have this, for the first one, we know this is a quadratic with a square. Simply put, we are having a parabola, and if the coefficient is positive, simply means that we are going to have what? Open upward curve. Now, so let's first find the intercept on both x and y axis. If x is 0, y will be 0. It means the curve will pass through here. If y is 0, x will still be 0. Then, if this is 1, this will be 1. So 1, 1. If this is 2, this is going to be 4. So 2, 4. You see, it's going to be upward. So we are going to have our curve this way, which will be y equals to x squared. Then for the second one, we are having y squared. So for us to be able to have that, it should be y equals to the square root of, it become y equals to the square root of 8 what? X. And we know that if you are drawing a curve or sketching a curve for a square root of x, we are going to have it move this direction, as in it's going to move from the origin, because if this is 0, this will be 0. If this is 0, this will also be 0. So it will still be origin. If I have x to be 1, this will be 2 point something. So 1, 2 point, it will still be in that direction. But don't forget, the square roots could be positive or negative. So the x will still be positive. It is the y that will be negative. So it means the curve will pass here, the same time it can pass here. So I'll be having something like this, which would mean this value. If I'm looking for positive values, then I can also have the negative values in this form. So this curve becomes y squared equals to 8 what? X. But we are saying the interval of integration is from where? 0. Their intersection is from 0 to what? 2. So this is the region enclosed by the two curves that we want to find. So the region we are looking for, this is, and this could be a different integration, but their point of intersection is what we are looking for. We know that if you are finding the area, it is going to be the integral of the above curve over minus the below curve. So in this, which one is the above? Per inspection, I can see that this will be the above and this will be the below. But for accuracy's sake, we can pick a number from this range and substitute into each of the equations. The one that gives us the bigger number becomes the curve above. So between this interval, I can have 1, 0 to 2, I can have 1. Putting 1 here, meaning y is going to be 1. 1 square is 1. Putting 1 here is going to mean y is going to be the square root of 8, which will be 2.2 something. So this value is bigger than this value. Therefore, the above curve will be this. So our area will now become integral of the above curve, which is supposed to be y dx, but this is square. So we are going to have the y equals to this, which will be the square root of 8x dx from 0 to 2, that's the interval, minus the integral of the below curve, y equals to x squared from 0 to 2 dx. From the sums and the difference of integration, we can also group this by putting the integral sign at only one place, meaning your area will now become from 0 to 2 the root of 8x minus x squared dx. If you this is just like integration of sum, separating the integral sign on all of them, which is this. So we can bring it back by combining them so that we use the limit of integration only once. Now we can see that this square root is affecting the 8, it's also affecting what? The x. So we can break it down. We know that if you find the square root of 8, it's going to be 2 root what? 2. Then if you find the square root of x, it will still be the square root of what? X. But x is what we are looking for. And under integration, we are much concerned about the exponent. So we change this square root to become exponent of half. So in this integral, your area is going to be integral from 0 to 2 root 2x exponent what? Half. Then minus x squared, then dx. So now we have an exponent and exponent to deal with. We now, in the exponent, we increase by 1. So half plus 1 will give us 2 over 2 is the same as what? 1. So we add the top, 3 out of 2. Then we divide by the same 3 out of 2. So this area is going to be, this is a constant which can be shifted forward. So the same will remain 2 root 2 x exponent 3 out of 2 divided by 3 out of 2 minus, increase this by 1, will be x exponent 3 over 3, limit of integration from 0 to 2. Don't forget, this double division means that this denominator can go up to multiply. So you'll be having 2 up to multiply, give you what? 4 root 2 x exponent 3 out of 2 divided by 3 minus x exponent 3 over 3 from 0 to 2. So now we can do our substitution of the limit, starting from the upper limit. So in place of x, I put 2. That will mean that I'll be having 4 root 2 multiplying 2, 3 exponent 2 over 3 minus 2 exponent 3 over 3. This is for the upper limit minus the lower limit. Which, if I put 0 here, exponent this, multiply to be 0. 0 here, exponent multiply. So let me just say everything out there will be 0. So now we can compute this side. Right here, we are seeing that this could be 1 out of 2 multiplied by 3. So it means there is still a square root here. What I mean is that 2 exponent 3, like this. This is the same as 3 out of 2. 3 out of 2. So 3 is moved away, then 1 over 2 will multiply. So that will give us the root of, which is this, 2 exponent 3, which will be the root of 4, 8. So root 8. So 4 root 2 times root 8. The root will multiply. That is the radicand. Under the root will multiply. So 4 root 2 times this will be what? 16. 16, root of 16 is 4. So this 4 will multiply what? The root of 16, which will be 4. And I believe that they give us what? 16. So right here you're having 16 out of what? 3. So here I'll be having area equals to 16 out of 3 minus, this will be 8. So 8 out of 3. Since I have the same denominators, I subtract only the numerator, and that gives me 8 out of 3 square unit. So when we have the integration for area between two curves, the steps still remain the same. Find the intersection of the two curves, integrate them separately, find the difference between the areas of integration, then your answer will be right there for you. I believe this clarify your mind on integration of area bounded by two curves. Thank you so much for watching. Like, share, and comment. Share with somebody who you think will need this. Invite them to the family. Bye-bye.